Okay, in a given reaction sequence, we have to first identify this D, and then we have to name this D by IUPAC nomenclature. Let's get started. So the substrate that is given is alkyne. So let's check how to solve this. So this is alkyne basically, right? This is CH triple bond CH. So alkyne is given. Now alkyne is passed through red hot iron tube. Remember this. When alkyne is passed through red hot iron tube, this is given on NCRT of 11th class in hydrocarbon chapter. When this alkyne is passed through red hot iron tube, it basically undergoes a cyclic polymerization and form benzene. Now how this reaction goes basically, so for that we have to we need 3 mole of alkynes. So this is 3 mole of alkynes. These 3 moles of alkynes this way, this is CH, this is, and this CH triple bond CH. So this will undergo cyclization, and this pi bond which is present between these two carbon atoms will get shifted to the between these two carbon atoms, between these two adjacent carbon atoms, and will form a sigma bond. Similarly, this pi bond will get shifted over here, this pi bond will get shifted over here, and cyclization will takes place and formation of benzene will occur. So we'll have benzene as product A. Right, it's very simple. So in this step, first, when alkyne is passed through red hot iron tube, I can say a heated iron, then A product is formed, and this A is benzene. So benzene is formed in A. Now the second step is very simple. So when this A is treated with nitrating mixture, this is nitrating mixture, that is nitric acid plus sulfuric acid. Nitration will take place. It's a reagent used for electrophilic substitution reaction. So when A is treated with HNO3 and H2SO4, it will undergo nitration and will form nitrobenzene. So the B product formed will be nitrobenzene this way. So this is NO2, nitrobenzene, right? This B. Now, when nitrobenzene is passed, this nitrobenzene is then treated with iron and FeCl3. Now, remember, this is also given in NCRT in 12th class in chapter compound containing nitrogen, organic compound containing nitrogen, that is amines. When nitro compounds are reduced by using iron scraps, that is iron and concentrated HCl, this nitro group get reduced to amine group. So this nitro group get reduced to amine group this way. So this NO2 will get reduced to NH2. So these aromatic amines are formed. So this is aniline. Aniline. This is compound C. So the product C, the compound C will be aniline, that is aromatic amine. Now this aniline is then treated with, this is important, this conversion from C to D. This aniline is then treated with benzoyl chloride. So remember, this is treated with benzoyl chloride. This pH is phenyl ring, and this is C double bond O and Cl. So this is benzoyl chloride. This aniline is treated with benzoyl chloride in presence of aqueous NaOH. Which is basically acylation, or you can say benzoylation, to be more you can say accurate, you can say benzoylation. Benzoylation will take place. So this benzoyl group will get attached to this nitrogen basically. Let's see how this reaction occurs. If we take into consideration the mechanism, let's this nitrogen which contain lone pair will show a nucleophilic attack on this carbon center, which is electrophilic in nature, and this pi bond will get shifted to the oxygen atom. Okay, this nitrogen will contain positive charge. When this nitrogen is going to attach to this carbon center, it will attain a positive charge, and this oxygen will attain a negative charge. And after this reaction, this negative charge on oxygen atom will get shifted back to this carbon and oxygen. It will form carbon oxygen pi bond again, and this hydrogen from the nitrogen get eliminated with this chlorine. So this chlorine is eliminated with this hydrogen, or in simple terms you can say this hydrogen will and this chlorine is getting eliminated from these two substrates and reagents, and the product formed will be this way. This is C double bond O. Now this hydrogen, this chlorine and this hydrogen, it will get removed from the reaction, and this NH, this is N and this is H, and this will be a phenyl ring. So this group this group will get attached to this carbon center, and this chlorine and this hydrogen will get eliminated, right? So this is the final product D. This final product D is formed. Now this final, you can see this final product is amide. It's very simple, right? This is amide. This is the amide functional group. This is C double bond ONH. This is amide linkage. So this product is amide. Now how do we basically give IUPAC nomenclature to this amide group? So this we have to see what functional group is present, or what you can say alkyl group is present to the nitrogen. So to the nitrogen group, to the nitrogen atom, phenyl ring is present. So we can say N-phenyl. This is N-phenyl, and this is benzamide. Remember this. This is N-phenyl benzamide. So the IUPAC name of this compound D will be N-phenyl benzamide, or you can say this is also known as, okay, so this will be N-phenyl benzamide. So how this reaction goes, let's check it out quickly. So when alkyne is passed through red hot iron phosphorus, it forms benzene as A, and this benzene undergoes nitration and will form a nitrobenzene as B, and this nitrobenzene upon reduction with iron and concentrated HCl will get reduced to amine group, that is aromatic amines, or aniline is formed, and when this aniline undergo benzoylation with benzoyl chloride, it form N-phenyl benzamide. Now another important point is that this reaction is also known as Scotton-Beumann reaction. This is also known as Scotton-Beumann reaction. The similar reaction is performed with phenol. It's very important. The similar reaction is performed with phenol. However, this reaction also takes place with you can say amines or aniline, and amides are formed as product. Thank you.